Hey guys, Mr. Bowman here. This video is for those of us who didn't like the algorithm that we looked at in the previous video. It is a bit of a messy beast. And the learning objective we're going to look at is we are learning to use the guess and check method to find the shortest path in a network. Now, what's really important, if you're using the guess and check method, you can't just kind of eyeball it and spit out the answer. You must look at 3 different routes. So we must look at 3 different routes. And that's because it's not like a luck type thing. If you get it or you don't. To be a bit more sophisticated, to be able to justify what you're doing, you need to be more thorough, and that's why we need that number 3. So what I do is, and here the question was from the previous video, we're starting at A and we're trying to figure out the best way to get to F. I like to map out what I think the 3 quickest possible ways are going to be. So the obvious one, just visually, if we go across the top, so we go A to B, D, and then finishing at F. So path number 1. So as I said, A to B to D, and then all the way up to F. That number might not be very good because we are picking up a few of the big numbers there. So probably think of another way. Let's maybe think, well, let's go along the bottom and then through to F. So that's A, C, E, D, F. So that there would be option number 2. So we've got A along the bottom down to C, continuing down the bottom to E, up to D, and then finally finishing at F. So we can't really avoid that 11 no matter what. And then a third option, well, this 10 seems to be quite big. So what if we went to B and then we went down and then around? So we're missing that 10, big one. It does seem quite long, but there's a lot of small numbers coming up, so maybe that'll help us. So as I said, that was going from A to B, down to C, across to E, up to D, and then finally finishing off at F. So there are the 3 routes. Hopefully we got the right one. I'll be surprised if one of those 3 routes weren't the quickest one. Let's now get into the maths of it. So A to B was 4. So this here would be 4 plus, and then we're looking B to D, which was that 10, plus 10, and we're going to plus the D to F, which was the 11. So this route here would have taken us 25 units, whatever that unit might have been. Now looking at number 2, so let's start off A to C, so that would have been 2. So we're going to have 2 plus, we then did C to E, which was 3. And we're going to add that. We had E to D, which was that 4. So plusing another 4. And then finally, D to F, that's the 11. Adding those all together. So we've got 5, 9, 20 units. So far, that one there was quicker than the 25 we had before. And our final route, we're still using A to B, which was 4. So it's going to be 4 plus, we're then looking at B to C, which was their 5, and plus C to E, which was 3, and we got plus D to E, which is 4, and that was that part there. And then finally the D to F, the unavoidable one, the 11. So let's add those all together. So we've got 9 up here, plus 3 makes 12. We've then got another 4, which makes 16, and then the 11 gets us to 27 units. Now that we've got all 3 possible scenarios, we've calculated how long each of them take, we can, with a bit more confidence, conclude the quickest way to get from A to F will take us 20 units long, and it's A to C, all the way to E, to D, and then finally finishing off at F. We're now at the second example. This one we also looked at in the previous algorithm video, but let's have a look. And just a reminder, we're going from Bristol to London. And let's start off with path number 1. What do we think is going to be quickest? The obvious one is just down the middle. That might be quick. So we're going to go Bristol to Swindon. Again, we're writing SW because of Southampton. And then we're off to Reading, and then finally finishing off at London. Number 2, maybe going along the top might have been quicker. So Bristol to Swindon, and then over to Oxford, and then finally down to London. And then maybe doing the same thing along the bottom might also give us an extra route as well. So number 3, so we've got Bristol over to Southampton, through to Reading, and then finally finishing off at London. So they look like the 3 quickest routes. The one in the route in the middle, that was the 40, 45, and the other 40. So we've got 40 plus 45 plus 40, and that gets me to 125 units. I think in the previous example we were using the units as minutes. We're then looking at the next one. This one was the route along the top. So we had the 40, the 30, and the 60. So we've got 40 plus 30 plus 60. That combined gets me to 130 minutes. So not bad, but unfortunately still a bit slower than 125 before. And then the final route along the bottom, we had 75, 42, and 40. So we've got 75 plus 42 plus 50. Forgive me if I'm doing my maths wrong, but I think that's 157 minutes. And that one there was way longer than the other 2 options. So from this, we did our 3 options. We calculated how long each of them would take, and we can conclude that cutting right through the middle was the quickest option. I just want to note in both of our scenarios, kind of that direct route straight through the middle ended up being the quickest route, but we must use the 3 route approach. If you don't use 3 different ones, you can't be sure you haven't missed an answer. So you've just got to be sure, include 3 different routes to really see through your answer. So that wraps up how to use more of a guess and check method to help find the shortest path. A few of us might have found this a bit easier than our algorithm approach from our previous video. Thank you so much for watching. Now let's get into heaps of practice.